So in your chapter, you talk about Pascal's principle, which is the idea that when I press down on a fluid with a certain pressure, that pressure is going to propagate through the entire fluid. Now, because pressure is a force times an area, if I push on a smaller area with a force, and then I distribute that force over a larger area, the ratio of those forces to areas are going to have to stay the same. So let's take a look at problem 61. In this problem, we've filled up a jug completely with fluid so that it's all the way to the top. And then we're going to pound a cork into this fluid with a certain force. We'll call that F1, and this has an area A1 with a diameter of 2 centimeters. And then the question is, if we have this cork in contact with the fluid and we smack down on it, what is the force that's delivered to this larger area down below that has a diameter of 14 centimeters? So we know that the ratio of force 1 to area 1 has to equal force 2 to area 2. Now, looking at this equation, we can see if this is going to stay equal. If A2 goes up, right, F2 also has to increase in order for these things to remain equal. So what we're going to get here is that F2 is equal to the ratio of the areas times F1. So we really just care about this ratio of the areas here. Now area is, for a cylinder, would be pi r squared. And in terms of diameter, that would be pi d over 2 squared, which is pi over 4 d squared. So I'm going to go ahead and plug these in here. So I'm going to get pi over 4 d2 squared over pi over 4 d1 squared times F1. Those are going to go away since I've got my nice little ratio problem. So I'm just going to get the ratio of these diameters squared. So that's going to be equal to 14 over 2 squared times the original force. So that's 7 squared times the original force, which is 49 times the original force. So the significance of this is that if you hit this with a force F1, you're going to get nearly 50 times the force at the bottom and probably end up breaking the jar. So be careful.